In this video, we will be discussing a few trigonometric limits, which sound really scary, but are actually really not that bad at all. So let's dive right in. For these trigonometric limits, there are really just three formulas that you need to memorize, and they're right here. This is how you're going to see them in your textbook. The limit as x approaches 0 of sine of x over x equals 1, and then that flipped, so the limit as x approaches 0 of x over sine x equals 1, and then finally, the limit as x approaches 0 of 1 minus cosine of x over x equals 0. So notice that last one equals 0. Again, this is the way that your textbook likely has them written, but I like to have them written this way. I like to have k's in front of my x's, which are just constants. So the limit as x approaches 0 of sine of k times x divided by k times x equals 1, and the limit as x approaches 0 of k times x divided by sine of k times x equals 1, and then finally the limit as x approaches 0 of 1 minus cosine of k times x divided by k times x equals 0. What's important to note about these is that the coefficient in front of the x's are the same. That is really the only condition for these formulas to be true. It can just be sine of x over x. It can be sine of 12x over 12x. All that matters is that the coefficients are the same. And so with that, we're going to dive into some examples. The limit as x approaches 0 of sine of 4x divided by 4x. Now, a lot of people will just see the 4's and they'll know that sine x over x is 1, and then 4 times 1 is 1, and they'll say 4. But you're smarter than that. You remember that if the coefficient in front of the x's is the same, then it's 1. So the limit as x approaches 0 of sine of 4x divided by 4x equals 1. Let's look at another one. The limit as x approaches 0 of 1 minus cosine of 2x divided by 2x. Now remember, all that matters is that the coefficient in front of the x's are the same. And here, they're both 2. And so we know, right, we just look back at our formulas. The limit as x approaches 0 of 1 minus cosine of 2x divided by 2x equals 0. Because remember, the cosine one was the one that equals 0. The two sine ones both equaled 1. Let's look at one that is a little bit trickier. And honestly, this is kind of what your homework problems and your test questions are going to be more like. So the limit as x approaches 0 of sine of 3x divided by 3. Now we remember that we want the coefficients on the x's to be the same, right? So ideally we want a 3 in the denominator. So what do? Well, we can just put a 3 there, right? So what we can do is we can say the limit as x approaches 0 of 3 divided by 3, which is just 1, times sine of 3x over x. And now we can multiply anything by 1, so this is totally fine. And this can be rewritten as the limit as x approaches 0 of 3 times sine of 3x over 3x. And now we remember that our limit properties state that we can just pull that constant out of the limit and rewrite this one more time as 3 times the limit as x approaches 0 of sine of 3x over 3x, which is 3 times 1, which is just 3. So notice what we did here. We saw the initial problem and we recognized that, hey, this looks similar to our formulas at the beginning, but it's not quite there, right? We want a 3 at the bottom. So how can we get a 3 at the bottom? Well, we have to multiply by 3 over 3, right? Because you can multiply anything by 1 and it doesn't change it. So we multiply by 3 over 3, which gave us our 3 on the bottom, pulled the 3 outside of the limit, and then we could solve it easily. All right, let's do one more that is just a little bit trickier than the previous problem. And honestly, if you can understand this one, then you're good for all these kinds of problems. This is pretty much as difficult as it gets. Let's look at the limit as x approaches 0 of 2x divided by sine of 3x. Now remember, we want a 3 in the numerator, not a 2. And there are two ways to solve this problem. And I'm going to show you both ways. So way one is we think, okay, how can we get that 2 into a 3? Well, we can multiply it by 3 divided by 2, right? 2 times 3 halves is 3. So let's do what we did last time with 3 halves. So the limit as x approaches 0 of 3 halves divided by 3 halves times 2x over sine of 3x. Remember, 3 halves over 3 halves is just 1, so that's fine. So now we have the limit as x approaches 0 of 1 divided by 3 halves times 3 halves times 2x divided by sine of 3x. we will pull that 1 divided by 3 halves out, which just becomes 2/3, right? 1 over 3 halves is 2/3. So 2/3 times the limit as x approaches 0 of 3x divided by sine of 3x, which we know that that's 1, so 2/3. Let's look at method 2 now. And remember, there are no right or wrong ways to solve this problem. And okay, there are definitely wrong ways to solve this problem, but there's no one perfect way to solve it. So method 2. If we look at the limit, we notice that we have a 2x in the numerator, and we remember from our limit properties that we can just pull that 2 out, right? Because that 2 is a constant. So we can rewrite that problem as 2 times the limit as x approaches 0 of x over sine of 3x. And now we can just do exactly what we did in the previous problem, right? So we want a 3 in the numerator, so we just multiply by 3 over 3. So that gives us 2 times the limit as x approaches 0 of 3 over 3 times x divided by sine of 3x. And we pull that 3 in the denominator out, and we get 2/3 times the limit as x approaches 0 of 3x divided by sine of 3x, which is 1. So 2/3 times 1 is 2/3. And that really is as complicated as these kinds of problems get. Remember, we just have 3 easy formulas to memorize, and you just want the coefficients of the x's in the numerator and the denominator to be the same. And if they are the same, great, you're done. And if they're not the same, you just force them to be the same and then multiply whatever constants come out, and then you're done. It's really not that bad. And these should be pretty easy gimme problems if you see them on a test. So if you enjoyed this video or if you learned something, please like, subscribe, and I will keep the math content coming.